top of page, this is on page 579. We've got the definition of a rational equation, an equation that has rational expressions. In other words, you have fractions, and usually you have some variables in your denominators on some places with fractions. Strategy is, right, and we did it in the one before, we want to, I guess I can just go to here's what we just did in the, right, here's our strategy, highlighted. Get a common denominator. Just like adding and subtracting fractions, solving rational equations, the strategy is get a common denominator because we want to get rid of the fractions. As soon as you get rid of the fractions, as with this green arrow here, you send it back to a grade 9 solving equation. And that feels good because you now look at stuff that you did in grade 9 and you're like, wow, that was really easy. But you didn't find it easy in grade 9. Because you're doing it for the first time. But now you've done so much math since then, if you would look back at all the stuff you did in grade 9, you'd be like, oh, grade 9 math was so easy. But it wasn't easy at the time. So our goal here is to get back to a grade 9 question, because then it's really easy to combine like terms and isolate and solve. Right? We did that with this one too. Strategy, get a common denominator. Then you can multiply both sides by that common denominator, and that would just cancel those out. Because you're multiplying, and multiplying, dividing, cancel out. And then it becomes easy to solve. So we're going to use that in our examples here. Here's example 1. We're going to use our strategy. We're going to get our common denominator. And I'll leave space in front of this one. I'll leave space behind this one, and I'll leave space behind this one. So I look at my numbers, 2, 5, and 10. What's the lowest common denominator for 2, 5, and 10? 10. So this one would need a 5 and a 5. This one will need a 2 and a 2. And this one has the 10 already. Then I look at my variables. There's an x and an x, but this one is missing the x, so we'll get our common denominator. So this will be 5 over 10x minus 4x over 10x equals 1 over 10x. Once you get that common denominator, you're going to multiply this side and this side by 10x. And when you do that, all your denominators will go away. That's the idea. Probably you won't even show the green in this step. You'll probably just be like, ooh, all my denominators are the same. If I multiply both sides by 10x, they'll all go away. And you'll just put red lines through those 10x's. And at the next point, you'll be like, all that's left is my numerators. 5 minus 4x equals 1. Move the 5 over, negative 4x equals negative 4, and x is equal to 1. Another thing you're going to have to do in solving rational equations is we are going to have to list our non-permissible values and check. In other words, in this question, do we have any non-permissible values? Are we ever dividing with a variable on the bottom? Yes. X can't equal 0. We check. Was our answer 0? No. Our answer was 1. It's okay. But sometimes you will get an answer to the question that was a non-permissible value, and then you have to be like, nice try. You tried to trick me. You put an X through it, call it an extraneous root, because it appeared to be an answer, but it's not an answer. That can sometimes happen. But in this one, here's our non-permissible value. X can't equal 0. We checked it. It was fine. And everything is good. All right, let's do part B. Again, I'm going to leave space in front of the first one, 5 over x. Leave space behind the second one, plus 6 over x squared. I'll leave some space there, equals sign, and equals 6, which I could write as 6 over 1. And in solving these, I look at my denominators. I need a common denominator. We've got x, x squared, and 1. You notice this first one's missing an x. The second one isn't missing anything. So my common denominator is x squared. Double check. Did I get all my denominators the same? I did. What do I have on the top? This would be 5x plus 6 equals 6x squared. And once you get that common denominator, at this next step, we multiply both sides by x squared, and those will all just go away, which is really nice. So what do we have as a result? We have 5x plus 6 equals 6x squared. And now we have to say, okay, this didn't go back to grade 9. This stayed at grade 11. How do you solve an x squared equation? Yes. Make one side equal to 0, so you can use that zero product property. I personally like to make the side equal to 0 to keep whatever the x squared is positive. I find that easier for factoring, if we're going to factor, even easier for the quadratic formula. So now you have a choice. You can either use quadratic formula, completing the square, or factoring. All right. Does it look like it's an easy one to factor? Maybe we try factoring, maybe use quadratic formula. So what makes this one hard for factoring is that we have 6, which has 2 options, 2 and 3, 6 and 1. And this 6 has 2 options, 2 and 3, and 6 and 1. So unless you can go through a bunch of mental math things in your head, you may choose the quadratic formula, okay? Or you might just randomly check one of them and be like, ooh, if I do this, I get 9 and 4. Outside is 4, inside is 9. That makes 5. So if I want a negative 5, my 9 will have to be negative, 2 would have to be positive. But it's not bad if you want to use the quadratic formula for this. So then I get x is equal to 3 over 2, and here I would get x is equal to negative 2/3. What were my non-permissible values? Was I ever dividing in this one? Yes. X can't equal 0. This isn't 0. This isn't 0. So both answers are fine. Three, 4, 5, and 8 for practice.